Okay, we are going to do more rational functions. I'll start with a little review problem. So I want you to answer the same questions as you did on the last assignment. I want you to sketch a graph, label the asymptotes, domain, range, x and y intercepts. So pause the video and try it on your own. Okay, check your answer. You should have a vertical asymptote at x equals -2 and a horizontal asymptote at y equals 0, both labeled with their equation. You're not adding or subtracting anything, so that does not move. Okay. The x-intercept. This is the fancy way of saying y. Okay. When will 0 equal 1? Never. So there's no x-intercept. And we knew that because that's a horizontal asymptote. How about the y-intercept? What is y, or h of x, when x equals 0? So that's 1/2. So the coordinate is 0, 1/2. Okay, so that's all you know. Do you know how to sketch? This is a positive 1. So it's going to go through this point, approaching the asymptotes, and then there's going to be another one over here. Again, it's just a rough sketch. If you want to plot some points, feel free, but no need. Okay, the domain, all reals except -2. And the range, all reals except 0. Okay, so basically, we're going to make these a little bit more difficult. I'm going to show you an algebraic way of finding the domain, or the range, I should say, instead of just doing the translations, because they're not always going to they're not always going to be in this form. So let me show you how to get this answer algebraically. This is what you're going to be practicing today. So we know that these are the answers, but let me show you how to do it with algebra. So let's take the original equation, okay, and let's solve for x. Now up here we know our denominator can never equal 0, so x can be everything except -2. Well, let's solve this for x and watch what happens. So to solve for x, you need to multiply both sides by x plus 2. Okay, and that's going to give you y times x plus 2 equals 1. Okay, we're trying to solve for x. All you're doing is rearranging the equation. So what would you do next to get the x by itself? Divide by y, and then what? Subtract 2. Okay, so now that you rearranged the equation and got x by itself, looking over here, what would cause us a problem for y? Y cannot equal 0 because our denominator could never equal 0. So let's go back up to our sketch. Is that true? Is it all reals except 0? Yes. So this is looking at it graphically, and this is doing it algebraically. So the reason why I want to show you that is because we're going to change the looks of our rational function, which is our next example. Okay, so for this assignment, you're going to find the domain, the range, and the y-intercept, and it will say, and the zeros, which you should know is the x-intercepts. So let's talk about the domain. The domain is anything that x cannot equal. This does not cause any problems. We can divide into 0. We cannot divide by 0. So x cannot equal a -2. So our domain is going to be all reals except -2. Okay. Now for the range, we have to do the algebra on this because you don't know what this graph looks like. It's a non-calculator assignment. You have to show your work. I will be having you submit your work, so don't just graph it on the graphing calculator and think you're going to get the answer. So we're just going to write that as a y to make it a little bit easier, and we're going to try to solve this for x. So this gets a little bit harder because we have 2 x's here, and no, you cannot cancel those. So we're going to multiply this side by x plus 2, and we're going to multiply that side by x plus 2. Okay, so when you do that, you're going to get y times x plus 2 equals x plus 1, because these cancel. Now notice, you have an x over here and you have an x over here. The only way to solve for x is to get those x's on the same side of the equation. Okay, so we're going to have to use the distributive property here. We have xy plus 2y equals x plus 1. We want the x's all on the same side, so I'm going to subtract x. I'm going to move this to the other side. I'm isolating the x's. So for those of you who don't have great algebra skills, you're going to be a little challenged on these problems. We're getting the x terms on one side so we can isolate the x. Now how do you think we can isolate a single x? Well, you could factor it out, and you get y minus 1 equals 1 minus 2y. To get the x by itself, you divide. So now that all we did was rearrange the original equation and got x by itself. So what y value is going to cause us a problem? Well, again, looking at your denominator, you cannot divide by 0, so y cannot equal 1. So what do you think your range is going to be? Your range is going to be all reals except positive 1. So that's how you're going to do domain and range. Domain comes from the denominator of the original, and the range comes from the denominator after rearranging it and using your algebra skills. Okay, now we're going to find x and y intercepts. So the x-intercept, we're talking about the original problem, the x-intercept is when y is equal to 0. Multiply both sides by x plus 2. You get 0 equals x plus 1. So x equals -1. So -1, 0 is your x-intercept. Okay. For the y-intercept, that's when x is equal to 0. So y equals 0 plus 1 and 0 plus 2. So y equals 1/2. So that means 0, 1/2 is on the graph. Okay, so now that you have all of that, could you sketch the graph? Well, let's take a look. We know that the domain is all reals except -2. So you must have a vertical asymptote at x equals -2. And you must have a horizontal asymptote at y equals 1. And then you have some branches. Well, this is a little bit different. It's like, well, where do the branches go? Okay, because there's not a constant on the top. So where do you think the branches go? Well, let's take a look at our points. We have an x-intercept of -2, 0. We have an x-intercept here. We have a y-intercept at 0, 1/2. So that's right around there. So what do you think the sketch is going to look like? Well, it can't cross asymptotes, and it has to go through these 2 points. So one branch is right here. And if you used a graphing calculator, that might be all you see. So I don't want you using a graphing calculator. You need to know if there's one branch over here for the rational function. There's got to be another branch over here. So you can sketch the graph after you find out all of those values. Okay. Let's try one more. Sorry, ran out of paper. Okay, I want you to try this all by yourself. F of x equals 2x plus 1 all over x minus 3. Find the domain, rearrange it to find the range, find the x and the y intercepts, and then sketch a graph. So I'll write that down. Find the domain, rearrange for x to find range. Did I say range? Find the domain. Find the domain, find the range, find the x-intercept and the y-intercept, and sketch. Okay? Pause the video and practice. Okay, check your answer. The domain should be negative infinity to 3, not including 3. So all reals except 3. Your range should be negative infinity to 2. You need to practice rearranging for x. I'm not going to show you all of the work because you need to practice. Your denominator should come out to be y minus 2. So there is your range. Okay. Your x-intercept. Your x-intercept. What did you get for your x-intercept? get negative 1/2. Your y-intercept, you should have gotten negative 1/3. Okay. And then your sketch. Oops, let's go back up here. Which one did I write wrong? My y-intercept. Y-intercept is 0, negative 1/3. Okay, so that means that this branch is going to go through here. So where is the other one? It's going to be over here somewhere. Again, we're just sketching. And there you go. So that's what you're going to practice on the next assignment.